Okay, we'll start the class now. Last class, where did we stop? Rutik?
Yes, ma'am.
Yes, ma'am.
हाँ last class कहाँ तक किया था रे? Where we have
Uh,
done?
मैम लास्ट क्लास 4:16 डिकोडर का वहां तक हुआ था मैम। उसके
Hmm,
नीचे का टॉपिक कवर करने का था।
construct this one, right? Suggest a scheme to construct 4 to 16 line decoder.
हाँ, ये होता मैम।
Was this understood?
यस मैम।
Okay, right? Okay. So next one, did you people go through the whole PDF? Others, did you go through the whole PDF? क्लास लेने के पहले ही भेजा है ना मैंने. You all are sitting here with your notebooks. Yes or no?
यस मैम।
Hmm. Okay. See, okay. Next is you are asked to configure a 5 is to 32 decoder. You are asked to configure a 5 is to 32 decoder using four 74138 ICs and one 74139 ICs. Okay. So 74138 is which IC? See, 74138 is 3 is to 8 decoder. Okay, it is 3 is to 8 decoder. So first thing what you have to do, you have to draw 4 3 to 8 decoders. Okay, so I have drawn, see this is my first 4 to 8 decoder, sorry 3 to 8 decoder means 3 input ABC, right, and 4 outputs, sorry 8 outputs Y0 to Y7. Sankal,
Ma'am, hello, Shubham, ma'am.
Shubham, this is your Shubham. Okay. See, you are asked to draw a 5 is to 32 bit decoder using 474138. So 74138 is nothing but 3 is to 8 decoder. So what I have done, I have drawn first 4 3 is to 8 decoders. Okay, so this is the first 3 is to 8 decoder. This is second 3 is to 8 decoder. This is third 3 is to 8 decoder. This is fourth decoder. Okay. Now 3 is to 8 decoder के लिए what I have done? I have drawn 3 inputs and 8 outputs. 3 inputs being ABC, 8 outputs being Y0 to Y7. These are active low outputs. Okay, and the enables being G1 active high, G2A and G2B active low. Okay, similarly, the second 3 is to 8 decoder, input ABC, output Y0 to Y7. Okay, this is third and this is fourth. Up till here, is that understood? Is it clear up till here?
यस मैम।
Hmm? Now see what I'm doing here.
मैम
Hmm?
मैम थोड़ा अंकिता को अलाउ कीजिए मैम।
Yeah. Hmm? Now see here what I'm doing is output of first decoder is from Z0 to Z7. Okay. Output of second decoder starts from Z8. It is up till Z15. Output of third decoder is from Z16 to Z23. Output of fourth decoder is Z24 to Z31. Because I am constructing 5 is to 32 bit decoder which should have 5 inputs and 32 outputs. So Z0 से लेके Z31 तक I have my 32 outputs. Okay, now out of 5 inputs I have given only 3 inputs, say D, E, F. Up to here, is that understood? Ankita? Tejas? Ratan?
मैम अंडरस्टूड मैम.
Yes. Right. Now, see, three inputs to हो गए. Okay, but remaining are two more inputs. Okay, so to implement those two more inputs, I'll be using my 2 to 4 decoder. Okay, so see, I have implemented here 2 to 4 decoder, which is having two input lines A, B, and four output lines. Okay, so if you see this 2 to 4 decoder, see, if your AB is 0, see, the first thing is this IC is on only if your G is 1. Okay, if your G is 1, so if 0 0 is given, right, 0 0 means your Y naught will be on. So see, here if you write 1, इधर एक bubble है, so here it will be 0, this 0 will come here, and it will enable the first 3 to 8 decoder. So any of the outputs from Z0 to Z7 will be high, depending on inputs D, E and F. समझ में आ रहा है? Understanding this? See, here G1 will be always connected to 1, G2 will be connected to ground. So 1, then G2A is X, G2B is 0. Now, depending on output from this 2 to 4 decoder, any of one IC of 3 to 8 decoder will be on. Am I clear?
यस मैम. मतलब तीन डिकोडर, चार में से एक, तीन बंद रहेगा ना मैम?
हाँ, चार में से तीन बंद रहेगा. At a time only one decoder will be on. Either of out of this four, only one will be on at a time. समझ में आया? ओके, राइट. देखो अभी, इफ ए बी इज 0 1, 0 0 में तो ठीक है, हियर इट वाज 1, वाई नॉट वाज 1. नाउ 0 1 में क्या होगा? y1 विल बी 1. ओके, एंड दिस y नॉट विल बी 0. ये y नॉट 0 होके क्या होगा? बबल है तो इधर तुम्हारा 1 आएगा. दैट 1 will come here and it will turn off this IC. Okay, now here 0 1 बाद इधर तुम्हारा आएगा 0, this line is to 8 decoder and enable this size. ओके, अभी इसमें से कौन सा आउटपुट ऑन होना है? आउट ऑफ Z8 to Z15 which will be activated depends upon this condition of D, E and F. Understanding? संकेत, पृथ्वी कितना है क्या क्लास में?
Ma'am, there is a network problem.
शाबाश, वेरी गुड. अबे
Yes, ma'am. Understood, ma'am.
हाँ, ओके, right. Now similarly here, if you have output as 1 0, 1 0 में क्या होगा? y3 will be on. Okay, it means here it is 1 and after bubble you'll get 0. It will travel along this line, come along this, come up till here and turn on the third 3 is to 8 decoder. So any of the outputs of Z16 to Z23 will be on, depending on the condition of this D, E and F. समझ में आया? Right? So for 1 1 your Y3 will be on. So here it will be 0. That 0 will travel here and enable this output, this decoder, and output will be zero.
मैम आपका वॉइस क्या है?
I can't hear you.
Okay, so is this understood? The 5 is to 32 bit decoder is understood?
Yes, ma'am.
Huh? So, iska, you have to draw the truth table for this, okay? You have to draw the truth table for this. It means your truth table should indicate for what combination of AB, which of your ICs will be on, and what would be the condition of Z0 to Z7 depending on the combination of D, E and F. Okay, so tomorrow you do it today and send it to me by evening. Okay, hardly it should take 20 minutes. Okay, shall we proceed?
यस मैम.
Hmm. Right? Okay. Next, you are asked to implement the multiple function f1 of ABCD given as SOP Okay, summation stands for SOP 048 10 14 15, and F2 is given to be SOP again 37913 using two 74138 decoders. Okay, now what is 74138 decoder? 74138. Okay, 74138 is this only. See, it's a 3 is to 8 decoder. 74138 is 3 is to 8 decoder. So what is your work? I said two 74138 decoders पे करना है. So your work is first draw two 74138 decoders. Okay. Then should I draw and show you, or is this enough? Explanation in PDF is sufficient, or should I draw and show you the procedure? Someone, until and unless replies, I don't understand.
मैम तो F1 F2 उतना ही ड्रॉ करके कीजिए मैम। वो
F
थोड़ा
of 1.
F2 उतना ही कनेक्शंस करके एक बार दिखाइए।
Okay, right, I'll show you here. Now see, you are asked to draw or give the function, right, to implement the function using two 74138 ICs. Okay, so your first work is to draw two 74138 ICs. This is first IC and this would be your second IC. Okay, this is your first work. Next, we know that it is a 3 input function. So I'll draw 3 inputs. Okay, these are 3 inputs. Then I know it is having 7 outputs. Okay, 4, 5, 6 and 7. Okay, this is having 3 inputs and 7 outputs. Okay, and it is having 3 enable. 1, 2, 3. Correct? Now आउटपुट क्या है आपका? This one, right? Y0, Y1, Y2, Y3, Y4, Y5, Y6. Okay, I forgot one more. Y7. Outputs are, say here I'll write. Okay, Y0 to Y7. Say I'll write A, B, 4 input, right? B, this is C, this is D. Okay, now G1 has to be 1. So I'll connect this to always plus V, C, C, and G2B, G2B, connect this to ground so that this is always at 0. Okay, now this is my second IC. इसको भी 3 input है, A, B, C are 3 inputs. Then G1 is 1 output. Then okay, one more thing I forgot here. See, you are understanding?
Yes, ma'am.
You all are understanding? राइट. सो मेरा ये G1 डैश हुआ, सेकेंड इसका, दिस इज G2A and this is G2B. G2B I'll always ground it, okay, along with G2A. Now इन दोनों में से IC number 1 and IC number 2, I have to first, my first work is to select which IC should be on. So see here I have taken three inputs B, C and D. A is left out, so I'll take A, I'll connect it to this, okay, and second is one more connection, I'll give it to G1 dash. It means if your A is 1, then this IC will be disabled and this IC will be enabled. Okay, second IC will be enabled. And if your A is 0, your first IC will be enabled and second IC will be disabled. Okay, now these three inputs, B, I'll connect it here, C, I'm connecting it here, and D, I'm connecting it here. Okay, and again these outputs are Y naught, okay, with inverter, then Y1, Y2, okay, then Y3, Y4, Y5, Y6 and Y7. Is it understood up till here? Is that understood?
Yes, ma'am.
Hmm? Okay. Now it means these outputs, okay, these outputs, I'll name it as Z0. This is my Z1, Z2, Z3, so on up till this is Z7. Okay. This IC output starts from Z8 and ends up till Z15. Okay. Now function is what? 0, 4, 8. Okay, so I'll take 0, I'll get a 0, I'll get a 4, Z4, then I'll get Z8, 4, 5, 4, 5, 6, 7, 8 is here, okay, 8 is here. You all try doing it. By the time the PC works, you try doing it. So I'll take this Z8. Z8, then you have 10, 8 now, this is 9, this is Z10, Z10, then what else is there? Z10 and Z10, 14, 15. Okay, Z10, then this is Z14, okay, and this is Z. Up to here, is that understood?
Yes, ma'am.
Yes? You are understanding up to here? Sanket? संकेत नहीं, सुरैया बानो, सुरैया बानो,
Yes, ma'am.
अभय,
Yes, ma'am.
Okay, right? Abhi, this is what min term, right? So what I'll do, I'll put a OR gate, okay, and give you a function f1, okay. But here I have a not, okay, I have an inverter. So before connecting to this, I'll put an inverter so that the two inverters cancel out each other. Done up till here? Understood up till here?
Yes, ma'am.
Understood F1?
Yes,
Right?
ma'am.
Similarly, we go to F2. Your our function F2 is what? 379. देखो, see F1 and F2. Is that understood now?
मैम अगर एक ही Z3 अगर दो बार ऐसा कनेक्टेड है तो तभी क्या करना पड़ता है मैम?
Okay, if Z3 here also I have Z3, I'll from here. See, I'll take it from here and connect it to this. Over.
ओके मैम.
Okay, right? Now, see, you can do this. Implement f of xyz equals to pi of 1246 on a 3 is to 8 decoder. Okay? So, इसमें क्या करेंगे? What we'll do? We'll start with, you are asked to implement, see, you are asked to implement 1246 on 1 3 to 8 decoder. Okay? So, your first work is, you will take 1 3 to 8 decoder. Okay, you'll take 1 3 to 8 decoder. You will give it 3 inputs, 1, 2 and 3. These are your 3 inputs, say XYZ, and you will give 3 enable lines, 1, 2, 3 enable lines, and you will have to connect 4 outputs, Y0, Y1, Y2, Y3, Y4 and Y7. This X and Z. Now G1, this is your G1 or G dash, which is to be connected to plus VCC. It means it has to be at logic 1, and G2A and G2B have to be at logic 0 for the IC to be on. See, this is G2A. I don't forget this inverter. This is G2B. These outputs are like this. Okay, outputs Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Okay. Now you have to implement 1, 2, 4, 6. Okay. I'll get 1, I'll get 2, I'll get 4, and I'll get 6. Okay. Now what I'll do, I'll connect it to this. Now these bubbles will cancel out and you get the output F. Is that understood now? Any doubts here? Any doubts?
No, ma'am. No, ma'am.
Sure? No doubts? Sure? Ankita?
Yes, ma'am, no doubt.
Okay, right? Abhi dekho. Here, the question asked is for pi. It means POS hai. But what I have drawn is same like this. Okay, however, this was SOP. Abhi aaya doubt? See, I have drawn it same na here. This and this figure are same. See, same gate I have used. So what you have to draw here is, I'll put one more not here. See, समझ में आया? Then this function will be pi. If you do not put this NOT gate and directly connect the output, it will be a summation. Right with this? अभी ठीक है? You all are doing it in your notebooks? See? So I've implemented summation or f of x, y, z. These are my three inputs, x, y, z. G1 is connected to plus 1 VCC, G2A and G2B connected to 0, Y0 to Y7 are the outputs, 1, 2, 4, 6. 1, 2, 4, 6 I have taken. To cancel out this bubble, I have put one more bubble, but since your output is pi, I connect one more bubble here so that I get a function in terms of POS. Now is that understood?
Yes, ma'am.
Yeah. Okay. Right. Now next one. Develop the logic diagram of a 2 to 4 decoder with following specifications. Have we done this earlier? 2 to 4 decoder we have done, right? In the beginning we had done 2 to 4 decoder. Right now here the thing to remember or to give a stress upon is they have said you to draw the 2 to 4 decoder with active low enable input. Okay? So when we are drawing this IEEE symbol, okay, see G ko you are going to give a wedge. Okay, you are giving to give a low. See, it is active low enable. So enable should be active low. Okay, active high bolne se, see it is as good as like this G. It is getting directly connected, right? But G2A and G2B are connected via a Not. So G2A and G2B are active low. So here what he is saying, you have to draw 2 to 4 decoder with active low enable input. Matlab enable should be active low, right? However, your output should be active high. It means, see, here the outputs were active low because here it was an inverter here. You know, you got a not get 0, right? But here, see, I don't put that bubble here. So I'm getting active high encoded outputs. Is this understood? IEEE symbol? Sai Prakash?
Yes, ma'am.
Is this understood?
Yes, ma'am.
Huh? Okay. So
Yes,
depending
ma'am.
on okay, right? So depending on this, we draw a truth table. Okay? See, if your enable, this is your G. If your enable is high, see, it means if I give a 1 here, 1 दिया तो decoder को आएगा 0. If it comes 0, decoder will be in the decoder will not be in the enable state. Okay, decoder will not be active. So see, what if your G is high, whatever be the condition of inputs A and B, your outputs will not be displayed. It is 0 0 0 0. However, your IC will be active only if your enable is low. Okay, if you give 0 here, you will get 1 and it will turn on the IC. So it is low, low, low. Then for 0, 0, Y0 will be 1, 0, 1, Y1 will be 1, 1, 0, Y2 and 1, 1, Y3. Is this truth table understood? I hope it is understood. Okay, next. So depending on this truth table, a logic diagram is created. See, Y0 is active when G is 0 and A and B are, it means A bar, B bar. Okay, so for see, for Y0, what I am taking, you can trace it here. I am tracing it with A bar and B bar, and see, third input to this Y0 AND gate is coming from this G0, which is having a inverter here. Are you able to understand this logic diagram? Understanding this logic diagram?
मैम एक बार एक्सप्लेन कीजिए वापस मैम.
See, to draw the logic diagram, you have to refer to the truth table. Okay, so this is your truth table. Just a minute. Okay, see, this is your truth table. Y0 will be active, 1, when your input is A bar, B bar, and your enable is 0. So, see, Y0 is equal to A bar, B bar. Okay, see, Y0, it's coming from here, A bar and B bar, and see, A bar, B bar, I got it from here. I have put an inverter here, and the third input, you can see this input is coming from this. It means if you give 1 here, then it will be 0 here. See, that 0 will be coming here. Okay, now if this is 0, see, if your G is high, it means अगर ये 1 है, it means तुम्हारा ये 0 हुआ. If this is 0, whatever be the combination, your output will be, disabled, right? So my G has to be low. It means here compulsorily you have to connect this to the ground. इधर अगर ये ground को connect हुआ तो इधर तुम्हारा 1 आएगा. If it is 1 here, then only all 4 gates will be active. समझ में आया?
यस मैम.
Okay, is this okay, everyone? Everyone, is
मैम
this okay?
Y3 को भी कनेक्टेड रहेगा ना मैम,
हाँ,
ग्राउंड?
Y3 को भी, हाँ, it has to be connected, correct. See, from here I have to connect it here. Okay, make a correction there. It is enable. Select enable है. You connect it here. Okay, I have missed that connection here. Okay, you connect it here. Third input. Shall we proceed? Okay. Next one. Implement the function pairs using 74138 decoder. Okay. Right. Now F1 is given to be SOP and F2 is also SOP. Now we are asked here to implement function for the minimum gate inputs. Okay. See, you had asked now, Rutvik, if both functions have 1, then what to do? Okay. Now we'll see it here. Here you are asked to implement using minimum gate inputs. Okay. Now see, this is a 3 input function ABC. 3 input means 2 power 3 matlab 8 outputs. Out of 8, 1, 2, 3, 4, 5. 5 are already here. Okay. So 8 minus 5 kitna hua? 3. It means what? What I mean to say is, I'll come to this. Now, here, if I say summation of 0, 1, 5, 6, 7. Okay, now this is given. Does it make any difference if I write like this? 0, 1, 2, 3, 4. Can I say these two are equal?
Yes ma'am.
Right? So I can say these two are equal. So how many input, what is the, see, you are asked to implement for minimum gate inputs. Input to the gates must be minimum. Okay, it means what? Here, right, see, here to this gate, how many inputs are there? 1, 2, 3, 4, 5, 6 inputs are there. Similarly, to this gate, there are 4 inputs. Correct? Now, in this question, they are asking us to implement for minimum gate inputs. So, out of these two, if I implement which function, will I get minimum input to the gates? Pi or summation?
Pi ma'am.
Pi. Okay? So, what I'll do, instead of going for 0, 1, 5, 6, 7 implementation, I'll go for implementing 2, 4 and 3. समझ में आया? देखो, if I write F1 bar of ABC is equal to summation 2, 4, 3, or if I write it pi of 2, 3, 4, both are one and same. समझ में आ रहा है? समझ में आ रहा है?
Yes ma'am.
Okay, right. If you understand this much, that is more than sufficient. ठीक है? देखो, so first function what I have written 0, 1, 5, 6, 7, which was in summation. Now F bar I have taken here, F1 bar I have taken. So this would, I can implement it as POS. Similarly, here F2 is given to be 1, 2, 3, 6, 7 SOP. So here I'll take F2 bar, which is summation 0, 4, 5, or F 2 of ABC which is pi 045. अंडरस्टैंडिंग मैं क्या बोल रही हूँ समझ में आ रहा है?
Yes, ma'am.
प्रज्वल गौड़ा.
Yes, ma'am.
हाँ. See what I mean is here I have put bar, so I have taken summation here. इधर f1 of ABC is equal to pi of 243 भी लिख सकती हूँ मैं. ठीक है. So I have taken, see this is 74138 decoder. It means it is having three inputs ABC, one enable connected to +1 always, G2A and G2B connected to ground always, outputs 0 to 7. Right? Now I'll implement pi 243 F1. So see it is what? F1 is, see from 2 I am taking, see from 2, 3 and 4. Okay, 2, 3 and 4 I have taken. To cancel out these bubbles I have put a bubble before this OR gate also, and since this is a pi function I have put a bubble here. What we had done in last numerical here, we see this was a pi function, so I had put a bubble at the output also. So this is a pi function, I have put a bubble at the output. Understanding? This is your F1. F2 क्या होगा? 045. So from 0 I will take, see from 4 I will take one more, and from 5 I will take. To cancel out this knots, I will put 3 more knots at the input of the OR gate, and since this is a pi function I will put a knot here and I get a F2. देखो, go through this. Any doubts? Any explanation do you need for this? Okay, right? Similarly, the next one, you need to implement summation 0 to 4 and F2 is equal to summation 1 to 457. Okay, now what I have done here, see anyhow function F1 is having only 3 inputs. Now it does not make sense to take F1 bar is equal to, or F1 is equal to pi of 1, 3, 5, 6, 7. Okay, उसमें 5 input आ जाएगा. So what I have done, I have kept F1 as it is. However, F2 had 5 inputs, so I have reduced it to F2 bar. Okay, and taken pi function to be 036. समझ में आ रहा है? Understanding?
Yes, ma'am.
Okay. So see, again this is a 74138 IC, 3 inputs. Okay, you have to put here one G1 which is connected to plus VCC here like this. You have to put G2A and G2B, you need to connect it to ground. Okay, I missed connecting it to ground. You have to connect it to ground. Outputs are 0 to 7, Y0 to Y7. F1 is a function, direct function, summation 0 to 4. So 0 I have taken, 2 I have taken, 4 I have taken. Just cancel out these bubbles using one more bubble here and direct implement F1 with the OR gate. However, F2 function, it is pi 036. See, I have taken 0 from here, 3 from here and 6 from here, and since it is a pi function or it is a F2 bar, I have put one more bubble here and I get F2 bar. Now is that understood? Is that understood?
Yes, ma'am.
Okay. Shall we proceed? Exhausted? Shall we proceed or should we stop? Is that sufficient for today?
Yes, ma'am.
See what you do. Up till here you have understood, right? So next two more pages are there. Okay, just go through this, right? And one more PDF also I'll send you. One more decoder I'll send you a PDF. You just go through. We'll discuss it in tomorrow's class. But here this we'll complete it tomorrow. So you just go through. If any difficulties, tomorrow we'll discuss on this, right?
Yes, ma'am.